Hey, so today I just wanted to talk to you about software architecture diagrams using a method called C4. First, why do we care about software architecture? We care about software architecture to reduce the cost of changes primarily. So as this piece of software grows, we make choices. Those choices can make it more expensive to make one type of change over another type of change. Good software architecture is all about normalizing the cost of changes across the piece of software. It's about delaying decision-making about details, especially details that don't relate strictly to your business case. And it's about increasing the speed at which new developers can onboard and learn about your software. But this isn't a talk about software architecture and what makes software architecture good. Just a few things to get your brain flowing. Today we're talking about making sense of messes. So first, what is making sense of a mess? When and why should we be using architectural diagrams? What happened to using architectural diagrams? We'll talk about C4, and then we'll go through an example. So most software architecture is a type of a mess. What's a mess? A mess is a situation where things have ceased to become understandable. We don't know why they're not understandable. Things are hard to communicate about. People disagree on what you're communicating about. People disagree on the path forward. Messes are made out of two things, people and information. You need people to have information. Messes are when people have too much information, not enough information, or not the right information. Information is made from the way people interpret the arrangement of things, and things exist in a context, and those levels of context affect the higher or lower levels which the things sit in. Information architecture is about the way we arrange the parts of things to make them more understandable. It's just about layout, layout primarily, and the design of how a person encounters that layout. Architectural diagrams are a form of information architecture. So they're a small, tiny subset about communicating about software things. For more information on information architecture, I really recommend a book by Abby Covert called How to Make Sense of Any Mess. And you can check it out, it's free online. So when and why should we be using architecture diagrams? Anytime we want to describe the current state of the software and its structure, we want to align that understanding of what the software is with other stakeholders. We want to review the software for maintainability, structure, or dependencies, the key parts of software architecture, or we want to propose structural or behavioral changes. These are some great looking software diagrams. On the left is something that's on the Eclipse website. And on the right is something I drew on the whiteboard at work a few weeks ago. They're both incredibly useful. What happened to diagrams? There's a lack of balance out there in the diagramming methodologies between precision and ease of use. They're often either too complex and difficult to understand the language of, or they're too ambiguous and chimeric in that they are meant for multiple audiences and represent different types of things within with unclear notation. They're often not scoped for different stakeholders. So you'll have a situation where you've created a diagram that would be best read by an ops person and given it to a customer, or you've created a diagram that would be best read by a developer and given it to a support team member. In addition, the rise of agile software development has kind of pushed everyone away from upfront design and more towards sort of ambiguous, communicated box and line on a whiteboard sort of diagrams. They're mostly functioning as conversational tools. They're used so that two people can understand each other in the moment, but as soon as the context of that conversation disappears, that diagram's usefulness does too. If even to yourself, even to the two people who were having the conversation, I can go back and look at a diagram I made on the whiteboard and frequently not make heads or tails of it. So what if diagrams captured more context and were made appropriate for the level of information needed by the viewer? That's where C4 comes from. The 4 C's are context, containers, components, and code. C4 is a static description of a software system. So it has, it's about how the structure of the software relates to the rest of the software. It's not about dynamic operation. It's not about how that software is deployed, though there are other complementary diagrams that go with it for that. It's about different levels of zoom for different audiences that capture enough information for them to be useful to gather context and move between the different levels of zoom. When you're just getting used to a piece of software, you don't want to see the UML class diagram. It's going to be useless to you because you don't know where to start, you don't know what relates and what the bigger picture is. C4 is meant to be formal enough to be accurate, but informal enough to be understood with no training. So if you look at a C4 diagram and you are the correct audience, you should be able to understand everything it is trying to say to you with no training. And it's text oriented. The vague pieces of typical software diagram are uncovered by a liberal use of text in their creation. So let's look at the different diagrams. On this slide, I've kind of arranged a little diagram to the right and a little description of what the particular diagram is about to the left. So a context diagram's all about where the software system that you're working on or considering fits into the landscape of other software systems and how people use that software. So typically on this kind of diagram, you're going to see the personas that you've created or just generic people. In this little example diagram, we've got an administrator and we've got a user. You'll see the software system in question, usually the thing you're working on. And you'll see external software systems that are part of the landscape of using that software. And in each of those, you'll have a description of maybe the intents or use cases of those particular entities. You'll also see relationships, which are one-directional arrows with a description. And those relationships could be any sort of thing, but they describe how two things interact. And I'll get into which direction the arrow goes later. So context diagrams for all the project stakeholders. It's very infrequently updated, though occasionally it will be as the landscape changes. There's few technical details. This is all about the audience of high level understanding of what this thing is for. Next step down, we're kind of zooming in on the software system represented by this box here. Also, can you guys see where my mouse is pointing? Is that great? The container diagram's about processes, services, and data stores, basically anything that can be deployed as a separate unit. The container diagram kind of talks about how the different containers in your software system interact with each other and with external software systems they might talk to. We start to talk a little bit more about which technology is used. We start to talk a little bit more about what communication interface is used. And the audience is more about developers. For instance, this would probably be the first thing a new developer you're onboarding would want to see. Some of your users, support, ops, they would care about these things. The update frequency is fairly low. It changes when the relationship between containers changes. So fairly infrequent, only when you're adding a new major piece to the puzzle. A component diagram is the next level of zoom. We're basically zooming into a container here and talking about the major separate pieces of concerns of the software container. So in here, oh geez, I forgot to update the text inside these boxes. That's my bad. We can just imagine that they describe these components accurately. Okay, so these are the different modules of responsibility and the structural relationships between them. At this point, we're starting to talk about the direction of dependency in the software. So from a software architectural point of view, this is more about, it's trying to capture both the data flow, but also the direction of dependency within the system. And these will be updated more frequently as the architecture grows, shifts, and changes. It's about the lowest level of detail you'll want to go for most situations. This is mainly a developer-focused audience too. Then at the code level, we're just talking about UML. We can use a smaller subset of UML if we want, but it's the details. We're almost always creating these ephemerally or generating them from the code itself. This is typically only going to be a partial view of the system in order to describe some story about development between two developers. These things are basically throwaway and where your whiteboard box and line diagrams still make sense. So what's the anatomy of a C4 diagram? I've got a little example from one of my projects here. Down at the bottom, the first thing here is a name and when it was last updated. Oops, excuse me. There's also a diagram legend that you'll see at the bottom, which describes all the different entities being used in this diagram. You don't have to use the same styles that I'm using here. These are all just kind of adapted from another style for the purposes of this this talk, but as long as you provide a legend, then your reader should know what's going on. So never let either the name and update thing or the legend disappear from any of these diagrams that you distribute. And in the middle, you've got the diagram itself. And this is a system context diagram. So we always want to include the legend, the label, and the date. Let's talk about the direction of the arrows in these diagrams. If you don't know about this portion of the diagram, then you're probably not concerned about which direction the arrow faces. But from the purpose of from the point of view of a software architect, what something depends on is one of the most important pieces of well-architected software. And in our case, the arrow goes from what entity knows about the other one. So typically that arrow is going to be going from your less stable code to your more stable code, your more frequently changing code to your less frequently changing code, your more concrete code from your more abstract code, and your lower level or machine dependent code to your more machine independent code. And this is all about requiring fewer deployments for fewer components of the software and running fewer tests for fewer components of the software and making software easier to change as you move forward. A diagram should tell a full story. And in fact, often that means cutting parts of the software out of the story. In this case, I've taken the diagram from the last slide where we have a persistor which talks to the data store, which is persisting some stable component of the software, which is presented by the presenter. And we're just talking about the persistence element of the software. So let's only show it. We note that there's a partial view here in the container, and that's all we really need for this story. We want to tell somebody about development. So when we're talking about changes in our software, we're reviewing a particular feature, this is often the best way to do it. There's some supplementary diagrams. This one is one that I frequently use, which is a deployment diagram. It's basically the same as a container diagram, but with augmented boxes to talk about what type of infrastructure, what number of resources, and at what location we're deploying pieces. For tooling, you can do this with Post-it notes and a whiteboard and a picture. You can do this with diagramming software like I have. I mostly made these diagrams right here in the slide deck. Or you can do it with modeling software. Structurizer is something that's made specifically for making C4 diagrams and exploring software architecture. And there's a plugin for Plant UML, which you can use. I think that's free. So just a minute, I'm going to turn on the lights. What this really means is that I didn't want to convert all these diagrams to a dark theme. So here's a software context, a system context diagram for HoloStream. This is one of the major pieces of software that I'm working on right now. You can see that hopefully this makes it very easy to understand what's going on with HoloStream. It's a software system for adaptively streaming volumetric content to host applications. You can see that we're using the color here to highlight the things that are of the highest importance. we're considering our users. Looking into a container diagram, you can see I've kind of adjusted the styling and layout here to bring a component into this layer, which is part of the host application that consumes data from our HoloStream API. And it's easy to understand what that is because it's labeled down here at the bottom. But you can see the different containers we use that are part of running this software system. We understand what technologies these pieces talk to each other with and who's interacting with them. And then zooming into a particular container, the Unity player, you can see the different components of that piece of software and how they talk to other containers in the system and the application they're hosted within. And so that's just an example I wanted to bring you through. I'll make these slides available for anyone that wants to look at them. And turn the lights back out. Thanks. That's my presentation. If anyone has questions, comments, wants to talk about any of this stuff, that was a great time.
Awesome. Thank you very much, Devin. Let's scan, see if anybody's using the hand up thing. Doesn't look like we have any hands up just yet. If you do have a question, you feel free to hop in now. I guess maybe I would put a question to the group. Oh, we do have a question. Do we?
Hello, can you hear me? Yep. You guys hear
me? Yep.
Oh, yeah, okay. First of all, thank you. Really, really cool presentation. Okay, you showed us a little example of one of your projects. How often do you guys really use the code diagram? Because in this case, actually, I think you didn't use that.
Yeah.
And actually, in practice, I think it's hard to fit the code diagram, right? Because it's super ephemeral. So how often do you guys use this?
I virtually never create a code diagram that persists anywhere. I'll draw a code diagram on a whiteboard, and for a particularly heinous refactor, I'll make a code diagram. Okay. But that's usually much after the mess is created in the first place. You can often get there without that. It's also kind of one of those things, like if you have kids, it's like sometimes you gotta leave their door closed to their room. As long as the components are architected correctly.
That's it. That's it.
Yeah.
Okay. Thank you.
I guess I have a question. Do you guys persist any of these diagrams to GitHub or some other thing that can allow them to be versioned better than just PNGs or something?
Yeah, I do them on Google Drawings, so you've got file history there. No, it's probably I think it would be like if you're taking the modeling approach, like using Structurizer or one of the other tools, you can persist the text document that creates your model into your repos, and that's probably the preferred way of doing it. Our process at work isn't there yet.
maybe a good use for GitHub wikis too. Thanks.
We've had some success with Mermaid JS and GraphViz for diagrams as code.
Mm-hmm. And do you use a particular set of styling for GraphViz?
No, just the stock stuff. I mean, usually it's just something that gets embedded in something else. So
yeah,
we've just have a container that's already got it all built up, and then just generate it, get a PNG out, and just use that in the docs.
Yeah. The only comment I have on it is that if you can ship text with the doc with ease, that's easy to read and understand, then you get a lot more of the full picture on first glance. But if you're shipping it as part of what is already a textual description of software, then I think that makes lots of sense.
Thanks, guys.
Quick question. So my team really, really wants more documentation, and we definitely have communication friction between engineering and business, and engineering and our analyst team, and customers who want custom data projects and want to figure out where there's a good fit. So super see the burning need. Where have you had the most success? Like, which group of stakeholders have you had the most success shipping something like this for? I think at the beginning you said, this should speak to multiple contexts. Is there one that's really stood out as being kind of extra high ROI?
We've used them internally, where at this point, a lot of the time our developers sort of ignore them, except for people that are new to the project. The value comes from sharing these with customers and other people that are deploying our products. They want to understand what the different pieces are and how they fit together, what their purpose is. I think it's very useful for that. So if you have like one example would be if you're making a bespoke cloud product that somebody else could be deploying, I think that's a great place to use, for instance, a container diagram. And if you have anything that's extendable by your customers where they can add plugins or what have you, and those plugins might interact with other parts of the system, I think that's really useful too. Even from growing the set of very technical power users of your product who can answer other questions for other customers of yours, it's really probably a useful tool for that. So if you can have other people on your forums or wiki or answers page answering questions that would otherwise come to support, it's a good benefit, and supports another place.